Okay, so in this video we are going to talk about another example of how we can differentiate using the limit method. How we can differentiate a function using the limit method. Okay, so let's write g of t is equal to 1 all over t squared. And let's say we have to find the derivative of this function when t is equal to -1. That's g prime of -1. Let's say we want to find the derivative of this function when t is equal to -1. So what it could be using the limit the limit formula. Okay, so we're gonna do this just like I showed you in the last video. So we're gonna take g prime of t. We can find it using this. Okay, using the limit wave. That's the limit as h moves to 0. Okay, so this is the definition we are using to find the derivative of this function here. We are going to use this formula of that definition. So the limit, if we insert the limit as h goes to 0, so g of t plus h means what? Means this. This is our g of t, so we are adding h to the t. So it's going to be like this. It will be 1 out of t plus h, and then we will square like that. And then we will subtract this from g of t, and g of t is right here. So that is 1 out of t squared. 1 out of t squared. Divided all this by h. So I think you know how we can manipulate this so that it can become like this, easier like this. Okay, the limit as h moves to 0. So the way we can organize this, it will be like this. We can make it this way. Because this h is dividing everything on top of it, we can just put it here together with them. G t squared 1t plus h squared. We can just take this h up here, and then we combine these two things. Okay, we can do that, and I think you know how we can do that. Okay, and then what we're gonna do is just bring them together. That's gonna be here. Here we will have t squared minus now this one, which will be t plus h, and then you square it. It's just a simple subtraction of a fraction. You know, when we have fractions with different denominators, well, the way we do is just the same thing. So after that, what we're gonna do is we are going to simplify this part, the denominator. Remember, what we want is to simplify it so that later we can substitute h with 0. Okay, that is what we want. So if we expand that thing at the top, we get like this, is equal to the limit as h moves to 0. So here at the top, what we're gonna have is t squared minus t squared minus 2t h minus h squared. That's what you're gonna get at the top. Then we divide it all by what we have at the bottom, which is h t squared, and then in bracket t plus h, all of them squared. So we'll try to find a way so that we can eliminate the h here at the bottom. Remember, until now we cannot substitute h to be 0. If you substitute h to be 0 here, you're gonna get 0, because 0 times everything here is gonna be 0. You cannot also substitute here, because if you substitute here, it's gonna be 0 also at the denominator, and you cannot divide a number by 0. So here you can see we can simplify t squared minus t squared, these two cancel each other, so we will have is equal to the limit as h go to 0. So what we have is minus 2th minus h squared all over now everything at the bottom, which is h t squared t plus h and then squared. So what we can do here is we can factor out h here, we can factor out the h here at the numerator. So how we're going to do it, instead of rewriting it and it will eat more space, we can just clear up everything here. So I will just rearrange it, so it's going to be like this. We will put h outside, we will get minus 2t minus h. So now we can cancel this h with this h. Now we cannot worry of anything turning 0 at the bottom, having 0 at the bottom, if we substitute the limit of h to be 0. Now if you directly substitute, what you're going to get is this. You're going to get minus 2t because this h is going to be 0, this one. We will have all over t squared, and remember this h here, this one is also going to turn 0. This is 0 and this is going to be 0, so we will have t squared also at the bottom. Right? Yeah, because now if we substitute h to be 0, this one will be 0 and this one will be 0, so we will just have minus 2t at the numerator, and at the bottom we will have t squared, and here is t plus 0 squared, which is just t squared. At the end, what we will have here is just t power 4. Okay, that is what we will gonna get, those t power 4. So cancelling them, we will just end up with negative 2 all over t power 3. That is what we will have. Now remember, we need to find this. So this is going to be, this minus 2t all over t power 3 is our g prime of t. Is our g prime of t. G prime of t. So our g prime of t is just that one. Okay, that is our g prime of t. So it is just going to be this one. This one that you can see, that's minus 2 all over t power 3. Okay, here at the top, you remember we have this question. We need to find the value of g prime of negative 1. So how are we going to find it? We will just come and use that derivative we just found. So g prime of negative 1 will be just negative 2 all over. So instead of writing t power 3 like we have here, t power 3 at the bottom, we will just write negative 1. So it's going to be negative 1 cubic. So and that's equivalent to negative 2 all over negative 1, which will give us just 2. Okay, so that's how we found our answer eventually. It's a long method compared to the other way of finding derivatives, which I will show you in the next video, but at least you should know how to use the limit as well. Okay, so for now you if you didn't understand this example, you can view the previous example I showed. You can check the link which I will show here. Follow the link here above to see the previous video if you want. Inshallah, in the next video I will show you the other way of finding derivatives, the simpler way. Thank you for watching. See you in the next video.